All right. Hey guys, this video is going to be completely review. This is actually something that we went over in class before we all were sent home. Um, but given that I want you to take a quiz this week. It's not as easy to ask me questions. I just wanted you to have a resource that would go over this again. Um, if you hear coughing in the background, that's my son. He has congestion. He's fine. Don't be worried. Anyway, um, so going back to the very beginning, a wave is a vibration that transfers energy but not matter. So remember with that slinky coil, like one coil would pass it to the next coil, which would pass it to the next coil. One coil didn't move from one side of the slinky to the other. So it's passing that energy down the line by one particle giving it to the next, giving it to the next, giving it to the next, and that sort of chain reaction. Or I think a couple of classes used domino effect to describe that through a medium. Okay, a medium, remember, is just the material that the object is going through. So when we did our first Slinky lab, the medium was the Slinky itself. When you're talking to someone, it's the air, right? So the sound wave goes through the air, and it's the gas particles in the air that are crashing into each other. And there's always a medium. So without a medium, sound or waves cannot travel. So that's again why there's no sound in space, is because there's no air, so there's no medium. This right here, this first picture, is a picture of a transverse wave. I didn't give myself enough space. I never give myself enough space. Okay, so this is your transverse wave. Remember, this dotted line is the equilibrium position. It's what the medium would look like if there was no wave traveling through it. And what's happening is this medium it's vibrating up, and then it's vibrating down, it's vibrating up, it's vibrating down. Okay, so the particle vibration is up and down while the motion goes to the right. That is those are perpendicular to each other. They're 90 degrees, right? So that's what makes it a transverse wave, is the vibration is 90 degrees to the motion of the wave. This here I've drawn a picture of a longitudinal wave. And so the same idea is that this vibration is going like left and right, while the wave moves this way. So that's our longitudinal wave. Okay. And so that just means that the vibration is parallel to the wave's motion. The motion is moving to the right here. Okay. So that's the very, very basic definition of a wave. The difference between transverse and longitudinal, and remember, the medium is that material that the wave is traveling through. So if it was like an earthquake, the material would be like the ground. It's just another example. I keep giving examples. Anyway, hopefully that helps. I'm going to make another review video about describing a wave from a graph, talking about amplitude, wavelength, period, and frequency. Okay, but that's going to be part 2. Great.